So, I would say Gulag. Welcome back, guys. So, had a bit of a rough patch there. Had a bit of a rough patch. Just gonna say that straight up. Yeah, okay, it looks like it's working. Yeah, so there's gonna be two separate videos. I'm gonna try to stitch them together. Hopefully that works out at least better than expected. Sadly, this room is super echoey. Can't really do much about it. So I had to get closer to the router, and the router is well, I'm basically in the room with the router. It's just that it's not a really good room to record in, and it's because I'm not. If I was in where I am or was, it would be fine. I would be perfectly content, and we wouldn't have these problems. I mean, unless the internet's down, then we just screw it. But anyways, let's get back to what we were doing. So we're testing if the registers were working. So I'm going to turn byte to hex string Java. I probably could just use byte.to hex string. Yeah. Alright. Or byte.to or integer print line integer dot to hex string, and then this number, but like, cast it. All right, so hopefully this works out. So we could, okay, yeah, that's right. 0A 0A. Yeah, that is correct. So that means that we can actually set this to FFF. If we set this to FFF, it will get overflow error, right? Yeah. So this is a byte. Wait, how much is a byte? Is a byte one 8-bit number? 255. 255B. How would I 1, 16, 17, 100, 200. Okay, so what's the limit? Oh. Just like when you start something according to Java like you did, like the first results were from Stack Overflow. Yeah, I mean, what else results do you get? And also, we have a problem because this apparently is a signed byte. I want an unsigned byte. How do we get an unsigned byte Java? Can we make an unsigned byte? Okay, so it's weird. Apparently, well, the problem is that it's a signed byte. I don't want a signed byte. I want an unsigned byte because I can do this. I mean, I could do that. I don't want to do that though. I want to be able to use an 8-bit number. An 8-bit number is 255. It's not 512, it's 255. But I can't use a byte for that. Do I just have to use integers for all and then just do all this checking stuff? Okay, byte, find, and replace with int. And then short, also do that. Replace all. And so I wouldn't have to do this anymore too. I wouldn't have to cast anything because they're all the same. I just have to do integers instead, and I have to do the same here. So instead of byte, I just have to do int, and then int. All right, so yeah, 8-bit number, an 8-bit number range. An 8-bit unsigned integer has a range from 0 to 255, or it's an unsigned byte because a byte is 8 bits. An integer is actually 32 bits, or it depends on what you can have big integer, which is 64 bits. But so I'm going to use an unsigned byte, which is a range from 0 to 255. And I don't want to use a signed byte. I just want to use an unsigned, but apparently Java doesn't support unsigned bytes like C and C# does. However, I can't use C or C not C#, what I'm saying, because I don't know how to use those languages as well as I do Java and all that. I mean, you can't even have classes in C, so like it's gonna be super difficult. And then C# and C++, I just don't know how to use it. Actually, you know what? Let's do it. Let's go to C#+, not C#. Oh my goodness. I have all the things to do it with. I don't want to save it. It's just that I don't really do it. Let me get out of here. C++. And like I don't really know how to use it as well as all this hello world. And then like it's all in here. Debug. I can run hello world. Enter number 6. Cool. I don't know what that did. I really didn't know what that did. Game. This is not it. I know this is. Yeah, I tried to make a game and I couldn't. So yes. So I really don't know how to use C++ or C#. JavaScript. Yes. Yeah, C# is basic. I could use C#. I don't know. So I guess it would be easier to do C#. It would, if it would be possible. I don't know. Well, I could do it in JavaScript. I could. I could. But then it would just have the same issues as before. I'll just stick with Java. I already closed out of everything. I'm sad. I was really sad. At least my RAM. Eclipse takes up so much RAM. Workspace. It's a very cool phrase about coding here. So I'm thinking of this. Does this have an echo? This does have an echo. I'm trying to figure out how to lessen the echo. I can do it in a freaking garage, and I can just echo, and all that. So I'll just suffer using an integer. It's actually a signed integer too, which is infuriating. Is that mine? It is mine. Well, anyways, so I'm actually gonna pull up the Wikipedia pages again. Move this wire out of the way. Shut up! I'm still gonna use Flash Player. History. 3 tabs. Okay, so we got the registers, and we can use this. There's also, we have 7 8-bit. Other 6 can be used as it, and depending on particular terms, which is also a neighbor. Free to memory, just pointed by the. So now we also need a program counter. I can do it up here. We need a program counter and a stack pointer. Most of these later on, like this is just, they're usually the same. So like if you're making a 6502, it's the only thing different is the registers and the instruction set, and the rest are really similar. So program counter is equals 0, stack pointer is also equals 0. And there we go. And now we can use, and we can do get all that. So source, generators, select all. This, I don't need any of that. And oh my gosh, they have double space and that sucks. That looks stupid as all can look stupid. Alright, so we get the program counter, we get the set program, get the stack pointer, and set the stack pointer. And so this is just because it's private, and I'm going to be probably spreading this out into multiple classes where it's game, source, relation, all this. Alright, so those are the register. We still got the flag register. And I know that is going to be its own class. Actually, I can actually fix that and do something pretty cool. It's called a status register or status flag or whatever, status flag, it doesn't really matter. And that's equal to 0. And for this one, we have to define it. Status flag. Excuse me. Forgot the. Alright, so what we need to do is we need to use a bunch of bitwise instructions, and these are the bitwise right here. We have the sign, we have the 0, we have the parity, the carry, and then the auxiliary carry, which is used for BCD. And that is pretty neat. The flags should be copied as a group to the accumulator. The A accumulator flags together are called the PSW register or program status word. So that is also complicated because it's also a register pair and it's not a register pair, and that's a problem. Oh, thank you. So bless you. That's nice. The carry bit can be set or complemented. Okay, and I know, like, the A accumulator and the flags together called the PSW register or program status word. That's really a special one. It's not really, it is a register pair, but it's not a register pair, if you know what I'm saying. Like, I can probably just make that its own class, to be honest with you. Or I can say register pair, and then have a boolean saying, what is it? I could probably just create a new class. Emulation, red program, status word, register. And this is going to hold the A register and the status register, and it can be combined together for stuff. So sorry about that. There's just a little door opening, and I didn't like. Yeah. So we need to actually create this class, and since it's only going to be used once, I mean, I could just make it, I don't know, like a separate, like in the register pair, but like as a special thing. But I'm just going to make a separate class for it. Hey, All Out Soccer, yes, this is pretty cool. I'm just gonna, I need to say, oh wait, I didn't get this out. make sure that you're connected to the internet. I am connected to the internet, sadly. I guess it's just because I'm using an old, outdated Eclipse version, and that's not fun. So I'm going to have private int and then register A, and this also the status flags. And this is going to have all the flag functions, and it's going to hold the register A. So it's really similar to this, except it doesn't have just general use stuff. It actually has some specific functions. So register A is equal to 0, and status flags is also equal to 0. Register, and then return register A, get register A, get status flags, and it returns status flags. Alright, and then we have the get register, and that returns all those things together. Is the status flag an 8-bit? It should be an 8-bit, and the flags are an internal status register. It should be 8-bit. Yeah, 8-bit. And then some of them are just unused. Can we reach 390 in this live stream? Too speed. We do need to reach 300. We need to reach 400. Not by the end of this live stream, but like sometime, please. Like, even though I'm not uploading as much as I want to, I still try to be active. I say that I haven't really done anything in the past couple of weeks. Well, the past couple of weeks, school's been there, and it's been going on, and it's been going in right now. I mean, nothing interesting has happened, but yet nothing mine. It's just started, and so I decided to focus on that, and yeah. So I also need to set this as set. So we have the register A and the status flags, and actually I don't think we need. I mean, we can have status flags like that. I mean, okay, yeah. And now I think we can keep this because I know there's a couple of functions that actually pull from the stack and sets that to the status flag, so we can actually set the entire thing to it. But then we also need each specific flag in it. So, so we need to actually describe which one is. So we have C, P, A, C, and S. And carry flag's the first one. And I think I could just do like public int carry public final int, and then I'd probably do static public static final int carry flag, and that's going to be equal to 1 shifted none over, and then we have to do the rest. And so this is so I can use them down here. So yeah, duplicate, that's the problem. I thought it was some other problem. So we need carry. We also need parity. So parity flag. And this is shifted to the left two times because it's in the second position because indexing. Auxiliary carry, and that needs to be 4. I'm just gonna have aux carry like that. Aux carry, we need 0 and sign. So 0 flag and sign flag. 0 and sign. And then those are 6 and 7 because of the last 2. And so what we can do is when we do public void get flag. We can provide it the flag it wants, so int flag. Oh, and then it needs to return, or needs to return a boolean saying if it's on or off, either the bit is on or off. So if, or I'm going to say int flag is equal to this, or status flags and the flag, flag state. And then we need to say return flag state is equal to 1. If it is, the return true. If it isn't, the return false. And that is for get flag. And then we need to have the set flag, which is a bit more complicated because we also need to take in a boolean and we need to turn it on or off depending on what that boolean is. So let's do that here as well. Let me just say set flag returns nothing. It needs the flag we need to set, and then on or off. So if it's on, then return on. So how do we do this? Until set a bit in Java. Here we go. Yeah. So we can turn it on by using this, and we can turn it off by using this. And thank you, Stack Overflow. Very cool. Copy. And so if on, we do this, else do this. And this is really like, it's just so later on I can see it and be like, okay, that's what I need to do. Then so my byte is going to be the status flags. And then we already have the flag. So flag. And then not the flag. Okay, so that should be it for this register, the special register. So in here, don't need the status flag. You don't even need register A. All we need is the program counter and the stack pointer. You need a private programs word register. What did you guys say? Register A, register PSW. And since we don't have register A or the status flag, and we need to say register PSW is equal to a new PSW register. And it needs parentheses. Alright, so now we can't really use set register and get register. We need to use get register PSW. Get. And actually, I can delete this and just use a getter. So source generate getter, select getter. Yeah, that's all I need. All right, and that will help us just trying to keep things all organized and actually go off of what this thing says, because where does it say that right here? The A accumulator flags together are called the PSW register or program states form. And so that's pretty good. example code. Alright, so copies that. So it moves register B to A. It does a OR A, and then returns return if a zero flag is set high. Alright, and then it needs to load A from address pointed by DE. It needs to move whatever is in the memory. Increment. Okay, so now that we have registers down, we can also we need to do the Z80. We also need to do the Z. Oh, I did cut. Okay, let me just open that in another tab. This is Z80 is a. Okay, so it uses more registers that aren't in the Z80, and I just want to know, see, look, AF, and the new registers, which we do not need. Here's the ones that I want. So they're all load and then all move. Alright. Where's the instruction set? Alright. So, random question. Do you have a pet? I do not have a pet, sadly. I really want one, but I do not have one. Z80 instruction set. This is it. Alright, yeah, this is it. Extended instructions, ED, and bit instructions, IX instructions. Man, there is a lot of instructions, holy crap. Here are the main instructions. How many instructions does the game? How many? What? How many instructions in Gameboy CPU? Ooh, heck yeah, CPU manual. Thank you. Oh, this is really good. Sad I do, which is crazy. Jumping around the house like a rabbit. She has energy 24/7 and doesn't let me sweep up. Wait, so what is it? Is it a rabbit or is it just jumps like a rabbit? Alright, Dang. Look at all these things. This is actually really good. Oh, wow, I could have used this. Oh my god, yes. This is really good. It has everything I need. Reserved memory addresses. So we have all this. We need that here. I actually need this right here. This is the scrolling Nintendo graphic I need. She's a cat. Dang, you cool. I wish I had a cat, but cool. That's really cool. What's her name? there's all these memory banks, but I don't care about. Alright, alright. All these are pretty good. Video. I want instructions. Oh, I might need interrupts too, but instructions. Oh, it's a kitten. It's a very tiny kitten. Yeah, kittens are really playful. I've not. It's been a while since I've seen a kitten. I've always either pet, like they're always adults. And oh, here's instructions. Yeah, they're always adults. Calling a cat an adult is weird. But yeah, so aha. CPU registers. Okay, so we got the AF, BC, T. Okay, yeah, we have that. Okay. Okay. Wait. This is the flag register. These are different. It has a 0 flag, the subtract flag, the half carry flag, and the carry flag. Okay, so that is not. I got the wrong flags, I guess. Which kind of makes sense because I looked at the wrong processor. So, good news is I only have to change this. So, we have the 0 flag, which is 0. The 0 flag is in bit 7. So 7, there's also only 4, so I can get rid of this sign flag. We have the carry flag, and that's in sign in bit 4, 5, and 6. And so we have the subtract flag, and I bet it's overflow. Is it overflow flag? Half carry flag. Alright, so just a little hiccup right there, but should be good to go. We already got the program counter. On power up, the Gameboy program counter is initialized to 100 hex, and the instruction is found at this location. So that is really cool. So stack pointer. Oh, this. Isn't nice. All right. Okay, so we have all the instructions. Yay! But how are we going to implement instructions? Well, shoot. Oh, we forgot to test the register. Probably should test them all. So, CPU dot get register, the PSW register dot set flag, and I want to set the carry flag, so PSW register dot carry flag, and I want to set that on, and I want to get that, so CPU dot get PSW register dot get status flags. actually want to set it to a binary string. So integer dot to binary string. All right, and this should just have one. Okay, yeah, that's right. And then if I set false afterwards and then print it again, it should set it to false. Here, I don't need a number. Alright, yeah, alright, so it works. We have, it sets the carrier flag to true, and then it sets the carrier flag to false. Good, that's what I want. And then the register A is, it's basically the same as the register pair, so I assume that works. And if it doesn't, you fix it. So now, we should probably get some RAM in here. Get out of here. So emulation.cpu. Should probably get some RAM. And I don't know how that is. Let me search RAM in here. RAM. Programmer. Alright, so that's the first one. I'm at the first one, right? Okay, that's the last one. Okay, program is all okay. So main RAM is 8K, and I know that can be mapped into more internal RAM. AK switchable back, internal RAM. Right here is what the general memory. So the 16K ROM bank, which is bank 1, and then that's like every single cartridge has, every single cartridge it has that, and then 18 kilobytes of the searchable ROM bank, which we can use. And then it has internal RAM, video RAM, and then the RAM bank from the cartridge as well, and then we have others. So echo of 8K internal RAM. So apparently this can access 64K, echo of it. Okay, so we have this weird echo RAM part. So I'm actually going to make the Gameboy class. So I'm going to get the package for CPU, so emulation.cpu. I'm just going to put all of these in this, and then okay. And then in there we need a new package called emulation.mem. So this is where all the memory is, the ROM, the RAM, and all that. So I'm going to create a new class called memory. And this is going to have all of the memory, all 64K of it. So we need to do public memory, and this is going to have the 64K. So we need a public or private, because we don't want to actually access this directly. So we need private what would it be? Int array memory. And so in here, we're going to say this is going to be a new int. It's going to be 64 times 1204. And that's the 64K right there. And then initializes it. And then in here, we need to actually initialize it all to 0. So memory arg4, let arg4 int I equals 0. I is less than memory hyperflow. Or memory.length, not memory, just straight up, so memory.length. Get out of there. And it needs to be set to 0. So all the memory in the entire Game Boy is set to 0 when it initially creates, and I'm probably just going to have a new class called Gameboy, which implements this all together. So Game Boy, and then public, probably just public CPU, so equal to new CPU, import CPU, and then public memory is equal mem is equal to new memory, and then import memory, and it's going to be from the emulation one, and that's pretty cool. So we have the CPU and the memory in, and then in memory we should probably have a read and write. So public int read address, and it's going to return. We actually have to specify depending on where we are in the memory. Interrupt enable register, internal RAM empty unusable for IO ports empty unusable for IO. So I think we can read to any of this, like any of it is readable to. And restart. So how does this work? I will be right back to get a drink. Alright, I am back. I got a drink and I even got a chair because I was sitting up the entire time. I think the entire time I've been live streaming I was standing, except for the first couple, like first 40 minutes, and I was sort of sitting, not really sitting because I can see from it. But anyways, I am back. I got a drink. Really good. I really like it. Alright. So I'm looking at instructions because memory. So yeah, the Game Boy uses information. Alright. So I'm just trying to get the memory down. So the memory map is all this. So we have 16 kilobyte ROM bank number 0, and then the switchable ROM bank. So the first half of the memory that the chip can access is to the ROM. So that means you can only read. So if the address is, so if address is greater than or equal to, that's minus, is greater than or equal to 0, and address is less than 8,000 in hexadecimal, which is like 32, then we're going to return memory of address. I'm just going to comment this ROM banks, and then right now I'm not going to be like doing switching banks. I'm just going to try to get the basics done. And so then I need a default one where it couldn't find it, and I'm just going to say return outside the range. So return null, or just I'll return -1. Wait, it can be negative. Return. How do I return nothing? Just return. No. Why can I not have no? Yeah, there we go. What is this? Like, that's just stupid. Why can't I just say return null? And apparently null is not a good type. I want to return an integer that's not possible. But -1 is possible, sadly, because these are all signed numbers. So I can't really use -1. I can use negative 255. That can't be accessed at all by any of these numbers. Yeah, that would work, but Java wouldn't really like that. Yeah, I can't really do return 0 because what if it's actually 0? Like, I'll just do return 0. It makes more outside the range. So there we go. This is the ROM. We have the video RAM, RAM bank, internal RAM, and this is the internal RAM as well. So I actually have to do something special with this on the write commands, because we can only write to these. Like, we can only write to some of these, and we can't write to anything that's ROM. We can't write to, because it's read-only memory. We can't write to read-only memory. Oh, so it's like an array. Yeah. I could do like a different type. I could do the list, but I just right now I'm not really looking for I'm not looking to save time. I'm just looking to get it working. If it works at 1 frame per second, it works, and then I can start optimizing it. But right now, I'm just trying to figure out how to do this. So the narrow empty space in the memory from many input ports except a switchable RAM pink. Yeah, maybe. Memory bank current one. Try to read this. RAM side, RAM destination code. I'm just trying to figure out. Okay, so where's the RAM located at? I forgot already. Anything OAM. Can I write to it? Can I write to the OAM? Gameboy. Alright, so I can write to it, okay. IO ports, unusable for IO, internal RAM, all that. I think I can read anywhere. I think I can read anywhere. So I don't even need a self statement then, because right now I'm just going to be able to read anywhere, and then I'm just going to be able to write anywhere, because, and then write void address and int data, and then say I don't need to return anything. I just need to say the memory at address is equal to data. I'm just gonna be able to write and read anywhere. Okay, and there we go. And that's pretty good. I'm not gonna lie, we have some memory in there. I'm also probably gonna have a load to ROM, so I can test stuff. So public void load to ROM, and it's gonna have the program. So I'd say the string, it's gonna be a string, so string program, and it's going to have a start, which is optional. So to make optional stuff in Java, you just create a second function without the argument that's optional. So you have load to ROM with just the program, and I'm just going to do this dot load to ROM with start with the program, and then the start's going to be at 0. So then I can don't have to copy and paste code a lot. So yeah, so load to ROM, we first need to turn the program into, because the program is probably going to be something like this, if I can find it. It's going to be like this. I'm just going to copy that. And I'm just going to test it. And that is going to be in the Gameboy class. Public string boot up is equal to this line right here. And wait, boom. And actually, I don't even need to be doing this. I could just Alright, so this is the boot up ROM that the Game Boy uses to obviously boot up and test that it's actually a thing. So I'm going to have that there. And when the Game Boy is created, I want it to load to ROM. So public Game Boy. And I want CP, or I want memory, not CPU, memory dot load. Memory. No, it's called mem. It's not called memory, it's called mem. Mem dot load to ROM boot up, and then start's going to be at whatever address that was. 104 button hexadecimal, 104 in decimal. 104 in decimal. 0x 104 in decimal 260. So at 2, or I can just do 0x 104. You can convert. And so that will actually load the ROM into the program into the ROM, which is what I want. So now I actually have to convert this into ROM. So I'm going to have a string array, just going to call this bytes is equal to program dot split with the regex as plus. It's expecting a string, right? Yeah, it's not expecting a character, it's expecting a string. So that's how we split up the bytes, and then what we need to do is we need to convert that, the bytes string into a number, and of course into that. So I think I've already done this before. I am just going to copy and paste the coding stuff. It's in JavaScript, emulation, and no, not this one. I've tried this before, or I tried a disassembler before. It's a lot harder. And is it in here? Where did I put this? I probably put it in here. And open with code. So I was also working on the first microprocessor emulator, and I've gotten pretty close to it. I haven't got anything showed yet. I've just gotten to the point where I can add stuff. As you can see, and I actually have a load to ROM right here, and it uses the same method. I don't need you anymore. So I can get you out, and I can actually just put you in there and just change a few things from JavaScript to Java, obviously. int I equals start equals bytes.length, and so this dot just memory of I is equal to string dot to integer dot parse int, and then so this will turn the string into an integer and then put it in the memory, and that should work out pretty good, hopefully. And let's actually create that in the main. Instead of just creating a CPU, we need to say public static Gameboy emulator is equal to new Game Boy. So now we can actually see if there's any errors. So there's no errors, which is pretty good. Here's what I want. I don't want any errors. Now I'm going to try to print out the system.out.print print line emulator dot mem dot read 0x1, and this will tell me if it works. 206 and 206 and that's supposed to be CE. CE in decimal is 206. Okay, so loading to ROM is working, and that is what I want. So it actually works really well. So I am pretty happy with that. And that's probably gonna be it for this live stream. We got a few good things done. We got the registers for the CPU, and then we have ability to load programs at an address, and this will be great for later on to when we have to have like the ROM loader, and we can just turn this into and then load it into ROM and then have all this memory bank switching and all that. But anyways, yeah, this is going to turn out hopefully like a little series on my YouTube channel. And yes, so hopefully next we can get some instructions in and we can do greatness. Anyways, I will see you guys later. And it's not like this is not like a different thing. We actually have to end the stream. So yeah, I guess I will see you guys later. Bye. How do I just end the stream? Okay, bye.